All right, welcome to systems of linear inequalities. So this whole unit's been about systems. You learned how to graph linear systems. You learned how to solve linear systems using substitution, and you learned how to solve using elimination. So we're going to look at how to graph linear systems. That's actually the only way to solve them because the solution is actually not a point, it's a shaded region. Okay, and that'll make sense in just a minute. But the steps are exactly the same. So we're going to tie in what we did at the beginning of the unit with what we learned last lesson to kind of put it all together today. Okay, so systems of linear inequalities are two or more linear inequalities that are graphed together. So if you think back to last lesson, we're gonna like combine problem 1 and problem 2, okay, on the same graph. And then we'll look and see where they overlap to find the answer set, the solution set. Okay, so a solution to linear inequalities is the overlapping and I'm gonna underline that because that's the key. The overlapping region of points that satisfies both inequalities. Okay. Okay, so let's look at some examples. So we're going to look at number 2, okay? Remember, step 1 from the last lesson was write the equation in slope-intercept form. Lucky for us, they're already in slope-intercept form. So I'm just going to take my time and graph those accurately. So I've got a y-intercept of 7, 1, 2, 3, 4, 5, 6, 7, a slope of 1/3, up 1 over 3. Okay, so check this out. Those are only 2 points. It's way easier to draw a line, a straight line, if you have more than 2 points. So a slope of 1/3 is the same thing as a slope of -1 over -3, because a negative divided by a negative is a positive. So to add more points, I'm going to go down 1, 3 to the left. So down 1, 1, 2, 3. Down 1, 1, 2, 3. Okay, so now I have more points. That's easier. Okay, using my ruler on my iPad. Oh, I'm going to draw. Am I going to do a dashed line or a solid line? Hopefully you said dashed because of the inequality right here, less than. Okay, so again, using my ruler, try to line this up on the, okay, so dashed. Okay, I missed my points, but again, it's really hard to line it up because the ruler is not actually on the iPad. Okay, that is a less than symbol, so I'm going to shade down here. Okay, now I'm going to use a different color. You are not required to use a different color for these graphs. It is helpful to see your solution set, but I'll show you how to mark it if you just use a regular pencil. Okay, so I would say you could probably use pen on this assignment. Whoa. All right, next equation is y-intercept of 4, so 1, 2, 3, 4, and a slope of -1. So it's -1 over 1, down 1 over 1, down 1 over 1. So there we go, there we go, there we go, there we go. So you got to be really careful because you're kind of like on top of your other equation. This one is going to have a solid line because it's greater than or equal to. So I'm going to draw a solid line through there. Use a ruler. Mario. Okay, again, missed my points. And my solutions are above that line. So they actually go like this. Okay. The solution to a system of linear inequalities is the overlapping region. So the area that they overlap is right here. So you can shade it in darker. That's a really good way to show it. Okay, so shade it in. Some people also like to write an S in there. Well, you can't even see that. Draw an arrow and write an S for solution. So if you can make it really clear by shading it, great. If you need to draw an S and an arrow, great. Okay, cool. Let's try another one. Let's look at number 4. So I wanted to do number 4 because, again, we have an equation with a single variable. So if you remember from last lesson, this line crosses the x-axis at -4. So I'm going to go over to -4, 2, 3, 4, put a dot, and it's going to be a dashed line. So using my ruler, notice I say ruler a lot. A lot of people don't use their ruler, and then it's really hard to see where the solutions are because it's a crappy line. Okay, the solutions are less than that, so I'm going to shade the left. Okay, this time I'm going to use the same color and then again show you how I do the shading. So the second equation is not in slope-intercept form, so I got to put it in slope-intercept form. So make sure when you're doing this assignment that you show the work that you did, because if you miss it, it could be because you did the work wrong and you graphed a different equation, but you still got the graph right. Or it could be that you got the equation right, but your graph's wrong. And as a teacher, I can't tell if you don't show what you did. So do that. So I got 2y less than or equal to -3x minus 2. Oh, did I divide by a negative right there? I subtracted. So don't flip the sign. Okay, now I'm going to divide by a +2, so I still don't flip the sign. So y less than or equal to -3/2 x minus 1. Okay, I'm going to graph that. So slope-intercept of -1, down 3 over 2, 1, 2, 3, 1, 2, down 3 over 2, 1, 2, 3, 1, 2. Okay, you can do it one more time. 1, 2, 1, 2, 3. You don't have to do it one more time, but you can. Okay, so now it's going to be a solid line because it's less than or equal to. So go back to my pen here. I'm going to really try to hit all my dots. Oh, you know what? I graphed that point wrong. Weird. Okay, I'm going to go back and fix that point. I should have went up 3, 1, 2, 3 over 2. Okay, so good job if you already noticed that. And I noticed it because it wasn't in line. So double check that your points should all be in line. Okay, so modeling mistakes. That's how we catch it. All right, solid line. Ooh, I hit him that time. So proud of myself. All right. These solutions are less than or equal to y. So I like to draw my thing in a different direction so you can kind of see where the overlap is. So can you see it? The overlap is right here. So it's all this. Yeah, I'm just going to leave it like that because it's dark and you can easily tell where it is. So when I grade something like this on the test, I look to see that you have the right equations graphed, so slope, y-intercepts. I look to see that one's a solid line, one's a dashed line, because that's how the equation was set up. And then I look to see that the shading is in the correct area. All right, cool. We're going to do one more example, and then we're going to look at a word problem, okay? So number 10, neither of them are in slope-intercept form. So again, show the work you did to get them into slope-intercept form. This one I'm going to put right here. So I'm going to minus 5x, and I get 2y greater than or equal to -5x plus 4. Divide everything by 2, 2, 2, 2. Y is greater than or equal to -5/2 x plus 2. Okay, so let's graph that one. 1, 2, down 5 over 2. 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. Okay, it's going to have a solid line because of the inequality. Okay, so draw my solid line there. Oh, that was good. I hit him that time. Yes. And it's a greater than or equal to, so I'm going to shade everything this way. Okay. Now let's put the other one in slope-intercept form. I ran out of room. So here, let's just, I guess, put it over here and write small. So I'm going to subtract x, and I get 4y less than -x minus 8. Divide everything by 4. I did not divide by a negative, so don't flip. Y is less than -1/4 x. So remember, there's a 1 in front of that x, or a -1, minus 2, because 8 divided by 4 is 2. Okay, it's teeny tiny. Sorry about that. Okay, slope-intercept. Point of -2 is my y-intercept. A negative slope of 1/4, down 1 over 4, 2, 3, 4. I'm going to go up 1 over 4, 1, 2, 3, 4. I'm going to do it one more time. Up 1, 1, 2, 3, 4. Okay. Sorry, I feel like I'm going a little fast. So if you need to hit pause and copy that, that's fine. I just know we're really good at graphing slope-intercept form. Okay, so this is going to be a dashed line. Okay, so going through my point. Oh, you know what? I did it again. I went up 2. Sorry about that. Okay. All right, so double check if your points aren't in a line. Fix them like I did. Okay, so dashed line. There we go. And y is less than that, so I'm going to shade below it. And guess what? The overlapping region is in this little triangle section right here. I'm going to darken it. Or remember, you can draw a little arrow and put S. Woo! Okay. All right. Last one. Let's talk about the application. These are going to come up in the next lesson. I just want to like set the stage for it. Okay. So Sarah's pet store has never had more than a combined total of 16 cats and dogs. She has also never had more than 9 cats. Write a system of inequalities and graph to show the possible numbers of cats and dogs in her store. Okay, so I'm going to say X is cats. It doesn't really matter which one's which. I always do the one that comes first in the sentence. And I'm going to say Y is dogs. Okay, so a system of inequalities has to have 2 equations. Remember, there's all those things you can write equations about. So I'm going to write an equation about cats because there's 2 things here. She's never had a combined total of more than 16 cats and dogs. So that's going to be one equation. The other equation is just going to be about cats. So let's do just the cats and the dogs first. So here's my first equation. She's never had more than 16. Does that mean she can have 16? Yes. So that means the cats, X, plus the dogs, Y, has to be less than or equal to 16. Okay, how do we feel about that? All right. My second equation is only about cats. So I'm going to put it down here for a reason. I'll show you in a minute. Cats, we said, was X, and she's never had more than 9 cats. So I'm going to say X has to be less than or equal to 9. Okay, how do you feel about that? All right. The first equation is not in slope-intercept form, so I'm going to do that first. So minus x. That's why I left the room there, space. Y less than or equal to negative x plus 16. Okay, now you've got this like graph over here. So we said cats were x, so I'm going to put cats along the x-axis. We said dogs were y. We can count by whatever we want. We're going up to 16. This graph looks big enough to count by ones. So I'm going to count by ones, but I'm going to label the 5s. So I'm going to go 1, 2, 3, 4. I'm going to put a 5 right here. Then I'm going to go 6, 7, 8, 9. And I'm going to put a 10 right here. 11, 12, 13, 14, 15. And I'm going to put a 15 right here. Okay, so counting by ones, labeling 5s. Let's do the same thing on the dogs. 1, 2, 3, 4. There's a 5. 6, 7, 8, 9, there's a 10, 11, 12, 13, 14, 15, there's a 15. Okay, cool. Now let's graph. Okay, so you have to be really careful. This graph isn't very good because it's so tiny, but we're going to do our best. Okay, so the y-intercept of the first equation right here is a positive 16. So I'm going to put a point at 16. The slope is a negative 1. So down 1 over 1, down 1 over 1, down 1 over 1. If the if the y-intercept is 16, what would the x-intercept have to be? Also 16. There can either be all dogs, 16 dogs, or it can be all cats, 16 cats. It doesn't say there has to be a minimum cats. So 16 and 16, I'm going to use that to draw my line. So instead of doing dot, 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 I just put a 16 down here. So This is a solid line. Okay, got this. I got my ruler going here. Notice there's no arrows on this line and I didn't keep going. Why is that? Because you can't have negative dogs and you can't have negative cats. Okay, and we're not counting ones that have passed. All right, so no arrows, they end. Okay, less than. So here are my solutions. So any of these ordered pairs down here would work. So she could have had 5 cats and 1 dog. That meets the criteria. She doesn't have more than 16 and she doesn't have more than 9 cats. But we got to check in with the other equation. Okay, so the other equation is x less than 9. All right, so remember that crosses the x-axis at 9. So I'm gonna put a dot right here. Less than or equal to, so it's a solid line. Ooh, so I forgot to shade that part. Okay, so solid line crossing the x-axis at 9. Okay, it can have an arrow on the top, but it can't on the bottom because again, we can't have negative cats. Okay, so check it out. This time, all the solutions are below it as well. But the overlap is here in this weird shape. It's a trapezoid. Yeah, so here's the overlap. Okay, so a great follow-up question would be, give 3 combination of cats and dogs that Sarah can have. Okay, if you pick any point in that shaded region, it's an answer. So I could pick this point right here and say it is 1, 2, 3 cats. So I would say 3 cats and it looks like 8 dogs. 3 plus 8 is less than 16 and she doesn't have more than 9 cats. I could pick something over here and label it. Let me ask you this. Could I pick this point? Does that work? It's on the line. It does because it's a solid line. So this actually is what's called the maximum, and this is the maximum number of cats and dogs she could have. So she could have 8 cats and what is that? 7 dogs. Okay, and that fits both criteria. 8 plus 7 is 15, and 8 is less than 9. Okay, so there is not a word problem on your homework, but I just wanted to set the stage because it's going to be in the next lesson, and just so you kind of seen it and we can build on it next time. All right, cool. So your homework is to finish this sheet. Okay, so remember, show the work you did to rewrite it into slope-intercept form, graph, and then clearly shade the solution set. Okay, good job. One more lesson. Woo. Okay.